right, let's get started. Hey guys, I hope you're having a nice conference. Today, I'd like to talk about agentic incident response. And I'm here to tell you that I think the future of incident response will involve agents. And you will only get paged in the middle of the night if your personal AI teammate is not able to fix an incident for you in production. But before I start, I'm really curious, just by show of hands, who here is or has on-call duty as part of their current or former job responsibilities? Please raise your hand. Okay, that's, let's say, maybe like 40%, not entirely like half of the audience, what I usually see. But something probably you can all relate to. And the way this like usually works is it happens at the most like annoying time. It's midnight, and you get a page, and then the first thing you do when you're on call, first try to understand what's the problem. Is this a real problem? Is it something that I can fix on my own? And maybe you are like part of an SRE team, and the first thing you discover is, okay, this involves an engineering team. So I need to pull more people in, and all of a sudden you're in a Slack room with 10 different people, and you start looking for a needle in the haystack, right? 2 hours in, you fix the incident, or let's say you contained the incident, there is no more business impact. What was the fix? It was a rollback. Why is it always the same, right? The same pattern. The reason is simple. The number one root cause for incidents to happen are changes, like changes introduced by humans, right? It's a human error that we make deployments, we make new software releases, we make a change in the infrastructure. Of course, there are sometimes other reasons why incidents can happen. And we saw 2 weeks ago, I think, was where half of the internet was almost like affected or down when AWS had an incident. That's, I would say, the third type of like root cause why incidents happen, when something you rely on doesn't work. The second most often root cause for incidents are when you have an unexpected system load, right? When you have more traffic than you anticipated. But really the most important or the most frequent root cause for incidents are changes introduced by new software releases, by patches, by changes in your infrastructure. My name is Birol. I run a software company in Germany. So we provide a SaaS solution for incident response. And we've been helping companies reduce MTTR. That's the mean time to resolution. It's the time between an incident is impacting your business and until it's no longer impacting your business, right? And historically, we've been the messenger of bad news. Like we would give you our product would give you a phone call saying that, hey, something is not working anymore, and like you need to fix it, right? It's not quite the best place to be in, to be associated with a product that wakes you up in the middle of the night to deliver you bad news. And now we're trying to make up for that. We're going forward, we're trying to be the messenger of good news. So instead of waking you up, we'll send you a report that says like, good morning, hope you had a nice sleep. There was an incident in the middle of the night, but no worries, your AI teammate took care of it. And by the way, here's the report. It was a brief outage. I fixed it, or we fixed it. And here's a PR that you might want to review for a like long-term fix. That's exactly what I would like to show you today. So I think agents are SRE's superpower. So if you break it down, what an agent does is, of course, we have automated lots of things in the past, like DevOps has introduced CI/CD pipelines, automatic scaling. So these are solved problems. And then for the past 2 years, AI coding agents have been on the rise. And I'm sure like anyone of you has used AI coding agents one way or the other. And it helps SREs as well. SREs, after all, they do produce code as well, after all. And some of them are also are involved in product development too. So we have Copilot, Windsurf helping with AI code generation. But what still remains manual is root cause analysis, and that's actually the most annoying part of what a site reliability engineer does. So again, if we break it down, it's system design. And system design is the creative part of an SRE, where you think strategically, trying to architect your system for resilience, and you want to like achieve certain business goals in terms of certain uptime goals that satisfy your business requirements, right? And then we have development, where an SRE would typically create, like reduce toil by introducing automations, creating workflows, and again, also contributing to products. But troubleshooting is still, there hasn't been a lot of work, let's say, where agents help you with root cause analysis. There are many companies now trying to solve that problem, and we are also among one of those companies that build now an agent that is doing root cause analysis for you. Before I start, I would like to share some of the learnings that we had building this agent. But before I start, let's quickly have a look at how root cause analysis works today. Usually, you have an external trigger. The best case is an observability solution that detects an anomaly, sends you an alert, and then the triage starts, which essentially like you're trying to gather context, gather data, and like see proof points for the symptoms you are observing in the system. Let's say you have a high latency, and then you're checking the metrics, you're checking the logs, and then you're trying to find a causal relationship between those symptoms and most likely changes that someone has introduced, right? It's like a search for a needle in the haystack, right? If you think about it, there is no real recipe for doing root cause analysis. It involves tribal knowledge. You have people just like applying their intuition and their own knowledge, and at one point you hopefully found the needle in the haystack. Before I continue, one thing I would also like to, let's say, recap is, what is the definition of an agent? Like, for the past 2 years, there's been a lot of chatter around agents, and sometimes I think it's not a binary choice, right? So sometimes people would call a workflow also an agent. So let's say I have a workflow where something checks my emails once a day, and I make a call to an LLM. Hey, these are my new emails. Please classify them and draft responses, right? And that's like running on autopilot. For many people, that's an agent. In our definition, that's not an agent. An agent is really an LLM interacting with an environment and deciding its own trajectory. So there are no steps where you would define first do this, then do this, then do this. Instead, you have an LLM running in a reasoning loop, orchestrating tool calls. And we'll get to that also in a second. And the way agents interact with your environment, with external APIs usually, or one way how this could be done is the MCP protocol, right? And I'm sure like everyone has heard of it. MCP protocol, it's like taking off. Everyone has built an MCP server. We'll also share some of the experience, or I'll also share some of our experience using the MCP protocol. But that's today how you would build an agent. So you would use a reasoning loop, provide it with like some sort of identity goals, and then equip it with tools. And tools are like, after the reasoning model, tools are the second most effective leverage to make an agent perform well. Because with tools, you highly ground the agent within your environment, and it is capable of like really querying relevant data to solve its problem. And that's exactly what we have built. So we have built an agent that is accessing. Is there a laser pointer? That is accessing these tools. In our case, these are observability tools or access to your cloud infrastructure and your code repository. And it processes alerts and incidents. And then it compiles a document or it compiles a root cause analysis consisting of key findings, recommended actions, and also related data where it's able to provide supported arguments based on evidence instead of like just some AI slop where it says, okay, I have this alert, probably it's this root cause analysis. And I'd like to make a live demo. And what I'm going to do, I'm going to simulate an incident. I'm going to simulate an incident by showing you an app. This is an app I have vibe coded some time ago. It's a to-do app. Like, it took me a few minutes, let's say, to build this app. And this app is like taking off. It's highly popular. And I've been getting so many requests and so many users that we can't keep up with the capacity. And I asked my team, how can I improve the performance of this app? My team told me, like, you should build a cache. This will massively introduce like performance gain. And that's what I did. So I arrived last night in Malmo. And then after the speakers event, I built a cache. And this is a pull request that I've merged, like, again, sometime around midnight. I hope it works. As you guys probably know, like, building a cache, like, I think someone said when I was studying, there are two hard problems in computer science. First is naming things, and the second is implementing cache invalidation. So whatever, I did my best. I built a cache, and this to-do app like actually works. I have a to-do, for example, for Tuesday, visit Helsingborg. And now I have my next to-do is to finish this talk. And however, when I make multiple requests to this app, there happens to be some like memory issues, which again manifest in this app being unresponsive. And this is not, no, that's the point. That's like, this is the sound some of our customers hear in the middle of the night. This is a critical notification. So my phone, so my phone right now is on Do Not Disturb mode. But because this is a critical notification, I'm getting paged. And usually this is something that happens in the middle of the night. So I'm getting paged, and without an agent, the first thing I would see is just this, right? It's this. Oh, sorry. Without an agent, oh, should have brought a mouse. It's just this, all right? So there is some, like, my application is not working anymore due to an out-of-memory error and was killed by the Kubernetes environment. And now usually what I would have to do is start digging and trying to find the root cause of this incident. And but because I have configured an agent, what this agent now is doing is it starts an investigation. And what I said, like in the previous slides, there are no specific instructions for the agent what to do. The agent is equipped with a set of tools and has this alert. And the goal of the agent is to find the root cause for this particular problem. Where is it? And now it is now like calling a bunch of tools, like including checking the pods, looking at related deployments, and checking the logs of the pods. Including checking the pull request that was recently merged from this deployment. And it's also looking at metrics just to see the memory consumption. And when it's done, it says investigation details are ready. So it took something that would take me usually like 10, 20 minutes, took the agent 2 minutes. So it's a 10x improvement, literally. And if we look at the key findings, again, this is live, like, and it's very consistent in its results. And I'll get to that in a second, why I think we're able to achieve this consistency. So it says, okay, this pod was killed. We knew that. And then it pinpoints actually the root cause. This PR, amazing cache, was merged after midnight, introduced an in-memory cache that stores full row packet data arrays per user with only a 5-second TTL. And the cache has no size limit. So that's one of the bugs I introduced, apparently. The cache has no size limit. And what else we have stores complete database result sets. Memory usage shows consistent growth patterns. So the memory usage grew from 38 megabytes to 128 megabytes across all 4 restarts. Let's see if there's anything else that's super interesting. Here, cache invalidation. The cache invalidation logic uses partial key matching, only user ID prefix. So there is apparently something wrong with my cache key, which manifests in wrong cache invalidation. And what else? yeah, I think that's pretty much the root cause. And if you look at the recommended actions, there are a few recommended actions. So first is, of course, I should review the pull request. I can do that. I can, like, if I click on this button, it will open the pull request I have like merged yesterday. But more importantly, there are two immediate actions where this would mitigate the incident. The first is I increase the memory, and I can, like, execute this or have the agent execute this action, or I can do a rollback. But the agent, like, by design, it is right now working in a read-only manner, and for any destructive action, the agent asks for approval. But I'm not going to execute any of these actions. Instead, what I'm going to do is I'll run this demo again, but configure the agent to run in fully autonomous mode. Don't do this at home. So this is essentially, right now, it's YOLO mode, right? So the agent will use its full power to fix the incident. So let's go back and let's resolve this alert. But we know it's actually not resolved. There is still the alert, so let's try to, like, in the meantime, probably this pod has been restarted by the Kubernetes environment, but we still have the memory issue. So if I keep on refreshing enough times, I will probably get another alert very soon. There it is. And what now happens, the agent is again kicking off, starting its root cause analysis. But this time it has the full power to fix the actual problem. Let me again double check whether I have enabled the autonomy. Yes, I did that. And here you can see, like, the tools that the agent is right now equipped with. So it has access to GitHub. It has access to the Kubernetes environment where these apps are running. It has access to our logging system. And what else? To deployment events, so everything that is related to like deployments. This agent will also is aware and can ask for information. So it is equipped with a bunch of tools to do its job. So now let's have a look at what the agent is actually doing. Okay, so now it is essentially like running the same root cause analysis, but this time it is right now patching the Kubernetes pod. So the memory consumption, the memory limit of that Kubernetes pod is now increased. Probably if I try to refresh the app, it should work and it should probably survive multiple refreshes because now the agent has applied an immediate fix. That's the, that's probably a safe mitigation just to increase memory, right? But what it's also doing, it is now creating a pull request that actually fixes the underlying issue for the long-term fix. Now, creating a pull request is a little bit of more work, takes 5 to 10 minutes, so we're not going to wait for that to finish. What I also wanted to check is, oh yeah, so what the agent also did is, the agent updated the status page where this application, so this app has a status page, and it has autonomously created an incident, updated the status page saying that this simple to-do service is experiencing crash due to memory leak in a new cache feature. It puts it to monitoring because it has already applied a fix, so it's working again, but it's just informing its user base what it's right now doing. Again, don't do this at home, but yeah, that's what it's doing right now. Now let's have the agent finish its pull request, and I continue with the presentation, and then we will have a look at the pull request when the agent is finished. So next, I would like to share a few learnings when building such an agent. I think right now, I know there is a lot of hype around AI and agentic behavior, but to some extent the hype is real. So there are like use cases where it really like adds so much value, 10x value in what you've been doing before. Like if you look at the root cause analysis, it took the agent 2 minutes, something that would take me probably 10 minutes. Of course, it's not going to work always. It's going to fail. But if you just look at the use case root cause analysis, what can go wrong? The analysis might be wrong, or the agent might say, sorry, I have no clue. But then you will just go on and do whatever you're used to do anyway. And we think right now there are a few things that contribute to the success of such agents. First of all, in the last decade, like we've invested heavily in observability. So there is a lot of data, and there's lots of signals in these data. But what we need to scale understanding of that data, right? Make meaning of that data, and that's where agents can help. And we have reasoning models. Very early on, we made a bet on reasoning models, and we built our entire agent like making that bet. We started a year ago where first we thought, okay, maybe we built an agent that operates a browser and that does exactly the same steps you would do, like log into Grafana, log into Datadog, check the dashboards, make screenshots, and then try to make meaning out of it. But we very quickly like throw that away, and then MCP came around, and then we thought, okay, we have a very high conviction of, and then sometime in April, May, like these reasoning models came along. And then we had a very high conviction that, okay, this is it. These are the puzzle pieces to build an agent that is like solving this annoying problem. And we do observe let's say, an appetite for agentic use cases. Or another way of saying this is we do observe a FOMO, right? So that's probably something every one of you knows. People think they are missing out. They need to try this new technology. And it is getting more and more accepted to use agents. Or like accepted in the sense that people want to automate things, right? And when something is useful, you're happy to hand over a task that is very annoying in the first place. 6 learnings. Built for reasoning, not for retrieval. I think this is probably the most important learning. So you have these reasoning models, but you can only benefit from them if you also like use them in a way how they're intended to be used. That means we don't use like predefined workflows. We don't tell the agent these are the 6 steps you need to execute. Instead, we keep prompts very minimal and the schema strong. And this benefits in 2 ways. First is, of course, when these models improve over time, you get to benefit from these improvements. If your prompt is too prescriptive, like even if the models get better, it will just follow your prompt, right? If you like very specifically say, check the logs, check the deployments, do this, there is no way the model can really like benefit from this. And of course, like having like smaller prompts makes like similar to code makes things more maintainable. And instead, we have a like strong JSON schema where we like expect something from the output of the agent, and we try to enforce that JSON schema. 6 months ago, this wasn't an easy task. Now it works pretty consistently that we can produce a reliable JSON output that we can then process. Third, right-size your tools. Like I mentioned, I think the 2 most important parts of this agent is leveraging reasoning models, and the second is leveraging the tools you have at hand. And we find that there is an art to like making these tool calls, finding the right scope for each tool, and also what's the acceptable number of tools that you can have in an active running reasoning loop. There are different recommendations. OpenAI, for example, says something along the lines of 10 to 12 tools. For our very specific agent, we think it's okay to have like around 20 tools. And like if you have too few tools, you limit the capability of the agent. If you have too many, then like it creates confusion, and you wouldn't get the results that you expect. The usefulness of an RCA agent an RCA agent increases with its level of autonomy. So the more tasks an agent can take over from you, the more useful it is. But this, again, is not a binary choice. So it doesn't have to be you're either you don't do nothing, you don't do anything, or you do everything, right? Autonomy can also be supervised, and we think of agent as like 4 to 5 levels. At the very basic at its basic setting, you would have something like a read-only agent. You could call this an L1 agent, and then there's where the agent only advises. The second level could be something like the agent still understands what actions are appropriate, and it proposes action. And then the third is for anything that is, let's say, not too risky. The agent will execute those actions after human approval. And then you might have like more destructive actions, for example, creating a pull request, merging it, deploying it. That's full autonomy, right? So there are nuances in between, and we recommend just starting small and then increasing the autonomy of an agent, because with increased autonomy, with increased trust, you also increase the usefulness and the benefits you're getting from an agent. MCP servers. I talked about MCP in the beginning. And there is a lot of hype around MCP. There are like thousands of MCP servers. And when we looked at it, it really sounded great. So we thought, great. So we, for example, have 100 plus integrations. And when we build an agent, we can just take the MCP servers of the vendors and have a reasoning model, like use these tools, and then that's it, right? But that's it's not the case. So we think when you want to build a very specific agent, having the right tools, things like having the right descriptions for these tools are critically important. So that's why we went with owning these MCP servers. So we don't, our agent doesn't use like external MCP servers. Instead, we host these MCP servers on our own, and we rewrite them for our own purpose. Sometimes there are big modifications, sometimes these are only smaller modifications. But what we observe is that these MCP servers from the vendors, they are like still immature, and we think you should own if you want to build a purpose-built agent, like you should own the MCP servers, because again, reasoning models, most important thing, second most important thing are the tools, and the reasoning model makes decisions based on the description of the tools, whether you want to call it, based on the scoping of the tools, right? So that's not something you want to have someone else do it. Instead, if you want to maximize for effectiveness, you should own these MCP servers, and that's the approach we went with. Yeah, and then probably that's something everyone does these days, use an LLM orchestration layer for different reasons. So we've built an architecture that makes the models swappable for different reasons. Our larger customers, for example, they want to use their own foundational model. They bring their own API keys for compliance reasons, for example. It turns out that a root cause analysis also consumes a lot of tokens right now. So it can be easily 200,000 to 300,000 tokens per root cause analysis. And we also like hit the TPM limits very fast with these providers. That's why we're using like many providers, and also to meet our customers' expectations with respect to like regional endpoints versus, for example, using the global endpoints provided by OpenAI. So to sum up, under the hood, we're using reasoning models. We have an LLM orchestration layer, and we own the MCP servers. We own and host them on our own. And we apply schema-driven reasoning with minimal prompting, a structured output, which produces consistent behavior. So let's have a look at the agent, what it did in the meantime. I have 10 minutes left. I think we're good on time. Okay, yeah, so it looks like that the agent is done with its pull request. So it produced this pull request. This is a coding agent where like it's a let's say a minimal coding agent that is capable of doing like these point fixes. In this case, it has like modified 3 files, provided a nice summary, and you can see here what it does. For example, like here it is introduced a, what's this? This looks like a TTL-based eviction, so after 60 seconds, if I'm not mistaken. I'm actually not sure whether this time it was able to fix it. So let's find out. So this time it looks a little different. So it doesn't really look like a fix to me. But let's find out. Let's merge this pull request. And when it's merged, then I think a deployment kicks off automatically. So this takes maybe a minute. And let's see if there are any interesting facts in the meantime. And one thing I didn't mention, if the agent happens to have a root cause analysis, you can also challenge the agent and just ask follow-up questions. So are you guys like curious of anything? Do you have a question in mind that I should ask the agent now? I'm not sure whether your fix is effective. Are you sure? Or what did you actually fix? Could there be any side effects? What was the second? Ah, okay. Yeah. Ah, true. I totally forgot about the memory increase. I need to revert this because otherwise I'm not able to verify the fix. Let's ask the agent to revert this. Okay. Right now, I'm not sure if it's under like it's doing something completely different. I asked about whether your fix is effective. I think it's probably referring to the memory fix. Let me see. Great question. Let me crave what has been fixed, what I actually fixed. Immediate mitigation, increased memory limit. Can you please revert the memory limit because I want to verify your pull request. And then what has not been fixed yet is okay. So it thinks I haven't like it doesn't know that I've merged the pull request. Therefore, it thinks it's still not effective. But let's wait for the agent to patch the memory again. So the new memory limits are back to its original values. So let's see if the pull request is effective. Let me check the deployment. Deployment is done too. Okay, let's see. This looks good to me. No. It did. I was a little bit suspicious because I think it didn't fix the. At one point, I'm using session IDs as cache keys, but I didn't see that it's fixed it. But I think it's still effective. Okay, it works. Let's. So I have now my colleagues chiming in and trying to see what the agent is doing. So these are other people looking at this alert. Thank you. I think you did a good job. It seems to be working, but I'm actually not sure whether you fixed the wrong cache keys, where I was using session IDs. It did? You saw it in the pull request? Ah, okay. Okay, and then I apologize. You did everything okay. So yeah, I think that sums up the live demo. I think I have one last slide. Wanted to give you a brief outlook what we're working next. What we're working on next. Now we have built like one decision we've made is not to build a monolithic large agent that you would give access to everything. Instead, we have like decentralized agents where every team has their own agent. So it's like onboarding a new SRE, and you say, okay, you have access to these services, to these logs, and so on and so forth. So the scope, the blast radius of the agent is somewhat limited. But of course, when like in large enterprise context, when you have incidents that involves like 5 to 10 teams, and you need to like the search space is really large, we will implement something like where we orchestrate multiple agents, and how we're able to search and reason effectively across a very large body of like logs, metrics, and traces, right? Because you cannot just dump petabytes or gigabytes of data into the context of an LLM. The second focus is we want to completely kill the 3 a.m. wake up for routine incidents. So there should be no reason to get up just to restart a service or to do a rollback. So when an agent is capable of applying a fix, verifying that the fix is effective, it should not wake you up. Instead, you should like see this the next day and then think about it long term. But of course, this requires more capabilities. For example, verification whether a fix is actually effective. Perfect. Anything? I'm happy to confirm that the fix absolutely addressed the session ID issue. Here's what was fixed. Okay, yeah, the cache key. Yeah, that's cache validation. Oh, it addressed everything. Okay, looks good. So there were 3 bugs, so it addressed everything. Thank you. We have 3 minutes left for questions. If we cannot take all the questions, I'll be also hanging around in the speaker's corner if you want to have a conversation. Please.
Shouldn't the first action be to just roll back your PR instead of fixing?
Yeah, I think the agent in the initial non-autonomous mode suggested 2 immediate actions, which like required human approval. One was to patch the memory. The second was to roll back. Because there are no instructions to tell the agent what to do, I think I think like doing a rollback is also risky because you don't like you need to at least be sure that the rollback can be safely done. Let's say you have, I mean, who does that? But let's say you have a version that is the previous version is incompatible with your database, for example, right? I mean, you wouldn't do this, but let's say. But I have no answer to this. So that's the first run. The agent proposed 2 actions: memory increase or rollback. But when it run autonomously, it just find that okay, apparently the memory consumption is rising, and it thought when I increase the memory from 128 to 512, this will buy us some time. And I forgot to ask the question, how much time will it buy us? Because it should be able to respond to that question as well, because it checked the metrics from Prometheus. So it knows how much memory was used in the last, I don't know, since deployment. Essentially by vibing. So we don't have, like, the question is, how do you test your SRE agent? So right now we have no sophisticated eval pipelines that make sure that this works. For us, it's still very early stage. So we do internally we do something called chaos engineering. So we can just have your DevOps dev environment and break it, right? And say and then ask the agent to fix it. So that's something that we do. And we have like these synthetic tests, like something I just showed you, with different problems, with different let's say potential incidents. And we're working with customers where customers use this not in the YOLO mode, but in the read-only mode where it does root cause analysis, and that's how we're approaching this right now. And one anecdote I'd like to share, when we were preparing this demo, where we were expecting the agent to update the status page, but it didn't. Then we asked the agent, like, why are you not updating the status page? I mean, this has business impact. And the answer was, look, this is running on a staging environment, so why should I update the status page, right? So, and it was absolutely right. I mean, okay, we're out of time. Thank you. Meet me in the speaker corner.